So a historic event in itself.
I have been so surprised to see these monsters. I'm on the air saying, look at this thing. Look at what this hurricane is doing.
As our weather becomes more extreme,
The hotter it gets, the drier it gets, the drier it gets, the hotter it gets.
The weather is wacko. This is a system shift.
water becomes scarce.
This is one of the main sources of drinking water. There's hardly any water in it.
Storms become stronger.
The rain now comes a lot angrier.
30 or 40 mile an hour wind howls for days on end.
And homes are destroyed.
We had the types of fires that humans just simply can't stop.
Extreme weather is taking its toll.
As the storms get stronger, as we lose more land, you lose a piece of who you are.
But across the country, many are fighting back.
This is my home. We're not going anywhere.
By innovating solutions,
We can substantially cool down cities without major expenditures.
marshaling ancient wisdom,
We're setting the landscape on a trajectory to accept fire in a good way.
It's worked for 10,000 years. It can work again.
and visionary ideas.
There's nothing we can't do if we use all the technology available to us.
We know what needs to be done. We just have to have the will to act and do it.
Weathering the future, right now on NOVA. It's all over the news. The weather is a hot topic.
The number of extreme weather events that force news directors to place us in the top of every newscast are multiplying.
Florida's chief meteorologist, John Morales.
John Morales has been covering the weather for over 30 years, and he's never seen anything like it.
There's more coming. I mean, it's crazy. The number of extreme events and just how extreme they get. I don't think meteorologists have lived through an era that's worse than this.
Wildfires, floods, drought. Disasters that were once rare, now hitting again and again. Extreme weather is the new normal in many parts of this country.
People see that it's raining with more intensity and hurricanes are intensifying more rapidly and the drought and heat waves are more severe.
The U.S. has always been home to a wide range of weather. Our geography and physics play major roles. The jet stream generally pushes weather systems from west to east. Those systems pick up moisture from the terrain below, like bodies of water and vegetation, then release it as rain and snow, as the air rises and cools.
Being between two oceans and having the Gulf of Mexico to our south and a large, dry, cold continent to the north, every extreme weather event that can be produced, you can generally find right here in the U.S.
So the weather naturally varies across the country, but we've gotten used to its predictable patterns.
Our whole climate, how we've set up our springs and our summer activities and our fall activities and what we do in the winter is based around a certain climate zone.
But now, things aren't so predictable, and the outcomes are more extreme. Seasonal fires are blazing year-round. Snowpack in the Sierras washed away by rain. And Midwestern farmers facing sudden downpours that scour their fields.
This affects our health. It affects the safety of our homes. It affects our water, our food, our supply chains, the economy. It affects every aspect of our lives.
What's causing these shifts? Many scientists agree that the underlying cause of much of this strange weather is more heat in the system, global warming.
Don't leave in their cars.
Oh my God.
It's okay.
Oh my gosh, that was our way home.
The weather is wacko. This is not just episodic, this is a system shift.
While people around the world work to cut carbon pollution and protect against future harm, what can we do about impacts from extreme weather that are already here? Across the nation, communities are already fighting back and finding solutions, demonstrating resilience, resourcefulness, and creativity in the face of extreme change. July in Atlanta, Georgia. Excruciatingly hot, muggy, humid. Researchers fan out across the city with one mission: find out just how hot Atlanta really is. Temperature might seem like an easy number to come by, but it's not.
Most cities only utilize a single thermometer to measure the weather. That is your basic airport weather station. And that is a rather ludicrous proposition. We need to be measuring temperature and humidity extensively across cities.
More temperature data could help save lives. Because when it comes to our changing weather, heat is one of the biggest killers.
I don't think people immediately think heat waves. They think hurricanes, they think wildfires, but heat is the silent killer.
Since the 1930s, average temperatures in Atlanta have risen about 3 degrees Fahrenheit. But the average isn't what matters.
When you shift that a couple of degrees, it puts you in a whole different climate zone. It's a bell curve. We're looking at a distribution of temperatures. A couple of degrees, a slight change in that average, shifts you into an entirely new area where the hots get put in extreme heat. That's when we have to rearrange our lifestyles.
Extreme heat overwhelms human bodies. Muscles slow, heartbeats weaken, blood pressures plunge, kidneys shut down. Days over 90 degrees have been linked to over 1,000 deaths a year in the U.S. So what parts of Atlanta are at the highest risk?
We know that some areas in Atlanta are hotter than others.
That's what Nataki Jelks, an environmental health scientist at Spelman College, wants to know. She equips students with portable sensors so that they can collect temperature data on the street.
How do we identify those areas that are most vulnerable? That's really what I'm looking at.
Nataki's measurements are starting to paint a clear picture. Some neighborhoods are a lot hotter than others.
We've seen 7 to 10 degrees difference in some places.
Mapping the data reveals the reason.
The data is telling us that areas that are most plagued with asphalt and concrete and a lack of vegetation are the hottest.
Vegetation, like trees, not only provides shade, but it also absorbs heat from the environment. But trees are often the first thing to go when cities expand.
We basically engineered cities to be hot. We come in, we remove trees. It gets hotter.
Since 2014, Atlanta has lost nearly 80,000 trees to development. And the materials replacing the greenery aggravate the problem.
We bring in mineral-based materials like asphalt, concrete, roofing shingle. That also renders cities hotter.
Concrete and asphalt make cities hotter because they absorb the sun's energy and re-radiate it as heat, even well into the night.
It's the warm nighttime temperatures that cause the health problems.
Human bodies can recover if they are given a break. So warmer nights mean more heat-related illness, especially for those who don't have air conditioning. And it's the neighborhoods that can least afford it that get hit the hardest.
There is this absolute connection. We planted our trees in areas that have more money and more resources compared to areas that don't.
With temperatures rising, can Atlanta and other cities undo the damage? Scientists say it is possible.
Cities can act today and really have control over the most effective levers to cool themselves down.
Phoenix, Arizona. With little vegetation to begin with, the city is even hotter than the desert that surrounds it. So they must find a way to cool the city.
Almost every summer, we have 100 days or more over 100 degrees, and regularly each summer we're exceeding 110 degrees.
To learn how Phoenix is coping with its heat, Nataki Jelks is visiting from Atlanta to meet with David Handula. He is charged with finding solutions to the growing heat crisis as the director of Phoenix's Office of Heat Response and Mitigation. It's the first post of its kind in the country.
You ever go into any of the cooling centers?
The cool air hit, and I feel the heat escaping me.
Phoenix hit crisis mode when in a 5-year period, heat-related deaths more than doubled to over 300 in 2021. And yet, David is optimistic.
While we look into the future, we're certainly expecting it to be warmer, but that doesn't have to mean that people are suffering at a higher rate.
To keep Phoenix cooler, David is pushing something in short supply: shade. The human body absorbs energy from the air around it. But direct sunlight can add up to 15 degrees to what the body experiences.
When we're under a tree, we've eliminated a lot of the incoming solar energy that can cause our body to heat up, and blocking that can be really impactful.
Shade is life-saving in a city like Phoenix.
Now, Phoenix is committing over $7 million to planting drought-tolerant trees over the next few years. But for these so-called cool corridors, it takes years for the trees to mature and the shade to pay off. Looking at the city's layout, another more immediate opportunity jumps out. About 5,000 miles of hot asphalt roads soaking up the sun's energy.
Anytime we can find hot ground and make it less hot, that will produce a cooling benefit with respect to the air temperature.
The idea is simple. Recoat the roads with a special sealant that will reflect about 35% of the sun's energy, which means less energy is absorbed by the asphalt and re-radiated as heat. In 2020, the city launched a pilot program to cover 36 miles of roads in 8 neighborhoods.
All right, so we're going to take a reading here with our infrared thermometer, and we've got...
But does it work? Heat-sensitive images taken from a helicopter reveal a striking difference. The more reflective surface is as much as 16 degrees cooler. And an MIT study projects that it could lower the average temperature of some cities by 2.5 degrees.
Now we are seeing new approaches which are really exciting for cities all across the country. We could wind up with a city of the future that's cooler than the one we have today.
We can substantially cool down cities in a relatively quick period of time without major expenditures. And so that's really good news.
The good news is welcome because it's getting hotter everywhere, not only in already hot places. In fact, models project the biggest increases in the north and interior regions of the country. By 2100, New York City could feel like South Carolina, Chicago like Montgomery, Alabama, Denver like northern Mexico. Rising temperatures agitate the entire weather system, dramatically impacting the cycle of evaporation, condensation, and precipitation. Some areas that are already dry get drier.
And so there's this feedback, as we call it, between heat and dry conditions and heat. The hotter it gets, the drier it gets, the drier it gets, the hotter it gets. That's what's happening in a warmer world.
The result? Extreme drought. The American Southwest is suffering its most persistent drought in 1,200 years, leaving no one untouched. The kind of drought occasional downpours can't break.
What's going on in California is We've transitioned from a prolonged drought to what's known as a mega drought, one that lasts numerous years.
Years that have created critical shortages of a basic need: drinking water.
So these aren't rain clouds. It hasn't rained here in over 2 months.
Mehul Patel is Executive Director of Operations for the Orange County Water District. 2.5 million people in Orange County, California, depend on him for safe drinking water. One might expect him to be extremely worried.
Is C2 going to go into a backwash? The pressure's super high. That's what we were always worried about. That's as much as we're going to get.
But he's not.
Yeah, exactly.
Because Orange County has turned to an abundant, nearly drought-proof source.
That's a good sign, you know. But
one that's only mildly disgusting. Wastewater.
Wastewater is anything that you generate in the home that ends up in a drain. That includes the toilet, the washing machine, the sinks. The yuck factor is difficult to overcome, but I think we need to be practical because the solutions are harder and harder to come by.
So, why wastewater? In many ways, they didn't have a choice.
The first thing to understand about this area is that 2.5 million people rely on groundwater.
Groundwater is mostly rainfall and snowmelt, captured in spaces below ground. And wells can tap it for drinking water. But by the late 1990s, Orange County's rapidly growing population was straining its supply. If the county didn't act fast, it could mean disaster.
This groundwater aquifer actually is physically connected to the ocean. And as the water level drops, seawater tends to take its place, meaning it'll infiltrate right into the groundwater basin and make it so salty that it's not potable.
The county was running low on water and time.
We only had probably 5, 10, 15 years before the point where we really got to find another source of water. The inability to have drinking water in an area with 2.5 million people is just not something that we could let happen. We had to get more water into the aquifer as quick as possible. 3 minutes, okay, and then see. But the challenge was, where do we get that water from?
One possibility was to take water from the ocean itself.
You can actually extract salt from the ocean water. You can turn it into drinking water, but it takes lots and lots of energy. And so that's done in really arid areas of the world where energy is more abundant and is not as costly as it is in Southern California.
They also considered pumping more water from elsewhere.
Water is today's California gold. Millions of acre feet held in reserve for future use.
Moving water from areas of abundance to areas of scarcity was the kind of mega engineering that made the modern state of California possible. Over 1,500 dams and about 4,000 miles of canals had been rerouting water across the state for decades. But the population had exploded, more than tripling since the 1950s. With the system nearing a breaking point, one thing was clear.
The old engineering solutions of the past just weren't going to sustain us going forward.
So they focused on a source flowing right under their noses. 200 million gallons of wastewater literally going down the drain every day. But how do you turn the county's dirty water into something people can actually drink? It starts at the Orange County Sewage Treatment Plant. Here, the largest solids are separated from the raw sewage, and smaller particles are allowed to settle to the bottom of enormous tanks. Aerating the remaining wastewater provides oxygen to pollutant-eating bacteria, which process the water to be clean enough to release into the environment. For decades, that meant all of the treated water was pumped several miles out into the Pacific Ocean.
Literally tens of millions of gallons a day just going out to the ocean, being lost essentially.
Could those millions of gallons be the solution to Orange County's dwindling aquifer and also make their system essentially drought-proof?
We knew that people had done water recycling. They just hadn't done it to a point where that water could be really efficiently reintroduced into a groundwater basin. But we knew it was possible.
Today, Mehul's plant finishes the job. It's a computer-operated system of airtight tubes and underground pipes. At the heart of the operation is a process called reverse osmosis, where 1,000 horsepower engines push the water through tightly wrapped membranes, filtering out impurities like pharmaceuticals, viruses, and salts.
So this is the end of the process. We can see how the water started out. You can see everything that was removed, and then you can see the purified water here that's safe enough to drink, but we'll still go through a couple more steps after this.
As a final step, they let the water seep back into the ground, replenishing the aquifer. Orange County's wastewater recycling operation is the largest of its kind in the world, processing up to 130 million gallons a day. And it is serving as a model for other California communities, including San Francisco, Los Angeles, and San Diego, all facing their own dry future.
I'm very convinced that a solution similar to this can be done in other places. You can follow the recipe in a lot of places where the same infrastructure exists. There's nothing we can't do today if we just put our mind to it and use all the technology available to us.
But drought is not only impacting drinking water. About 700 miles north of Orange County, the coastal forests are also thirsty. The rugged Klamath River region of Northern California is an outdoor paradise.
I love living here. I don't know if I could live anywhere else and be as happy as I am here.
These idyllic mountain valleys are home to tens of thousands, including indigenous tribes like the Karuk. But people here know that danger lurks in these woods.
We have to have our most precious things packed because you don't know how much time you're going to have to get out.
On September 8, 2020, residents of the town of Happy Camp get the order to leave. Fast. The mountains are on fire. Fierce winds and unusually dry conditions fuel the flames.
Those are the types of fires that humans just simply can't stop.
Fire ravages the town, destroying more than 200 homes.
A lot of Native people's homes burnt, and a lot of them had to move out. A lot of them were scared to live in Happy Camp again.
As bad as this is, it's not an aberration. In fact, between 2012 and 2021, over 24% of forest land in California burned.
The intensity of wildfires that we have now is just on a scale never known to indigenous people. It would never be possible to have this type of fire on the landscape.
That's because for thousands of years, indigenous peoples in North America had been using fire to shape and protect the landscape.
Fire is not inherently bad. This landscape evolved with fire. The species on this landscape are fire-dependent species. You can't take fire out of this landscape.
Fire clears out brush to make way for fire-resistant edible plants, like acorn-producing oak trees, underground bulbs and onions, and berry bushes that can sprout back after a fire. And it creates a diverse patchwork of forest and grasslands. A setup ideal for hunting wild game and gathering food from the forest. But starting in the 1800s, white settlers to the region saw these trees as a commercial resource and felt new towns had to be protected. Fire suppression became a U.S. government policy for over a century, and it became a crime to conduct intentional burns in this part of the country.
There really wasn't a lot of burning going on when I was growing up because it had been criminalized, particularly for Indian people.
You could get shot if you were Native for starting a fire. You go to jail.
But now the frequency and severity of fires in the West is increasing, decade by decade. Rising temperatures and cycles of drought play a part. But an aggravating factor is how the forests themselves have been managed.
You've removed fire from the system for so long, there's all that much fuel that builds up. And now, with an additional stressor added, like climate change, it really causes problems.
Without regular, low-intensity fires to thin them out, Western forests are now twice as dense as they were 200 years ago. And without the patchwork of already burnt land to stop their progression, they can spread across 1,000 square miles, destroying towns in their path. Fortunately, there's a solution to this problem. Now, the Karuk and other indigenous peoples are securing burn permits and bringing back their ancient practice. Literally, fighting fire with fire.
Just to start, this is a ceremonial ground, so it's important to take it really slow.
Today, tribal members are planning a series of fires they'll be setting downriver from Happy Camp, near the community of Orleans.
So we're gonna create a little bit of a black line right in here.
The fire is to protect the town and get that grassy area burned off.
Starting and controlling fires in this landscape, close to an inhabited area, takes skill.
It's specialized expertise to know when the wind's gonna be right.
Winds 0 to 2, gusts to 6.
When the humidity's gonna be right, when we should burn for something and when we shouldn't.
They wait until dusk, when it is cooler, less windy, and more humid to start burning. First, they carefully torch and then extinguish a patch of grass to create what's called a black line, a barrier to keep the fire from burning out of control.
That area won't burn. So you have a safety zone in between the places that you're not wanting to burn.
Then, they light fires across the field, careful to keep water hoses nearby to handle any flames that jump beyond the black line or threaten trees.
We're setting the landscape on a trajectory to accept fire in a good way. And we're gonna be way more set up for when we get to do larger scale fires.
The 2-day burn goes off without a hitch.
What we're doing and what we're advocating for isn't an experiment at all. We know it works. It's worked for 10,000 years in this place, and it can work again.
We're taking that next step in bringing fire back to the people. This idea of cultural burning. It actually made its way into the Secretary's executive order this past week.
Now, federal and state governments in the West see the wisdom of this approach. In 2021, the U.S. Forest Service used prescribed fire more than ever, burning nearly 2 million acres of federal land. And over the next 10 years, it has vowed to manage more than 50 million acres with fire.
What firefighters were trying to prevent is exactly what they are now facing.
But in 2022, the U.S. Forest Service made headlines.
One of the 2 fires was purposely set as a prescribed burn.
When a planned burn in New Mexico got out of control. High-profile escapes like this are a setback for proponents of prescribed burning. The resulting outcry can halt the practice for months, leaving the stage set for the next uncontrolled wildfire. But in fact, escapes rarely happen.
There's inherent risk in any way of managing fire on this landscape. We want the one that makes that risk the smallest possible. Less than 0.5% of prescribed fires escape. We don't see those same odds with containing wildfires. And what we know is that the relative risk of being organized ahead of time, of choosing your burn window, is night and day from the situation in a wildfire.
The current megafire crisis has opened up a chance for the Karuk to finally bring more good fire back to these mountains and reclaim some of their traditions while protecting the land.
Our place in the world is to manage the world, at least our piece of the world. And that's part of the reciprocity that allowed us to live here for so long on this landscape.
As the planet warms, many dry areas, like much of the West, get even drier as more water evaporates into the atmosphere. In fact, for every degree Fahrenheit that the air temperature rises, the atmosphere can hold up to 4% more water. But it can also release the added moisture, often in shorter bursts. Epic storms, historic floods.
When you finally get a trigger for rainfall, the rain falls harder. The rain rate is just so insanely high that you start to get runoff, you start to get erosion, you start to have crops being damaged by just the actual raindrops.
That's what's been happening in the fertile farmlands of eastern Iowa. On her family's 1,000-acre farm, Elisa McFarland raises corn and soybeans. She is the 6th generation in her family to work this land. And now she's taking over.
Thought I'd show you where I didn't plant.
From her father, Tom.
Exactly where we're at.
But she's confronting conditions very different from those her family contended with in the past.
The width of the irrigator, the 4th and 5th tower.
Temperatures are higher.
In the spring, it was 93 degrees, the second day corn planting, which is entirely too warm. It's normally in the 60s.
Winds are stronger.
It used to be once in a while you get a 30 or 40 mile an hour wind. Now we'll get it for days on end. It howls night and day, 24 hours a day.
And rainstorms are different too.
The rain now, it comes a lot angrier. Instead of having a storm roll through in a day and you have, an inch of rain, we had a storm roll through in an afternoon and we got 6 inches of rain. And things wash away. And you look at it and it's so sad because that's your land, that's your livelihood, and it's washing away.
The strongest storms in this region are dropping over 40% more rain now than in the 1950s, causing historic floods and sweeping away the topsoil that makes this region the breadbasket of America.
Soil erosion, I think, is an abstract concept for a lot of folks. They might not know what it means, be like, how did we lose soil? Where did it go? For a farmer, it's our livelihood. It matters where that soil goes.
Farms in Iowa are losing on average more than 5 tons of soil per acre per year. But surprisingly, Elisa's farm isn't washing away. That's because the way she farms her fields preserves the soil. Most farms in Iowa use a method that arose in the 1800s with the development of the steel plow. With these new plows, farmers were able to repeatedly turn over or till the soil after the harvest. This buried the leftover crop material and killed weeds. Looser dirt also made it easier to plant seeds at an optimal depth. And tilled soil tends to warm faster, promoting germination. The plow was a game changer that helped feed a growing nation. But now, as the weather grows more extreme, the downsides of tilling become more apparent.
If we see a bare soil like that, what happens if the wind comes? Well, those little dried out particles on the surface are going to be subject to wind erosion. What happens if an intense rainfall event happens? We'll get runoff.
Can you reach the spade?
Soil scientist Deanne Presley studies how different kinds of dirt withstand today's extreme weather.
And mill them into products.
She's here to see Elisa's approach.
So this is kind of the border between the two sections of this field.
Okay. It's kind of like a crime scene, right? And you can go look at that soil and understand things about it.
Elisa's soil looks different from the dirt on conventionally farmed fields. That's because she leaves her plow in the barn and lets the crop residue stay right where it is.
We're trying to minimize the amount of disturbance that we're doing in that soil. We're only disturbing the part that we really have to put the seeds in the ground.
Elisa is going back to the ancient method of plow-free farming with a modern twist. She uses a high-tech planter to push aside crop residue and apply the precise pressure needed to push seeds into the soil. In winter, Elisa grows cereal rye in these same fields, not to sell, but to shield the topsoil from the elements.
We have to put more stuff on the landscape to keep that soil protected. So that really big, really heavy, wind-blown raindrop doesn't hit the soil surface.
But how exactly does leaving the ground untilled fight erosion? It comes down to a soil's structure.
The stronger the structure, the better. Structure is the way sand, silt, and clay particles get organized together into units.
A soil with strong structure has a mix of these different sized particles, creating lots of air pockets, or pores. This gives room for roots to extend, gases to nourish the plants, and a home for other living things that add nutrients to the soil, all interwoven in a matrix that holds itself together. Left undisturbed, the soil builds structure. Tilling breaks down the soil structure, weakening it.
Scientifically, we have many studies that show that there is a huge decrease in erosion when we use no-till. That is a definite benefit.
In a hard rain, pore space in soil gives excess water a place to go, much like a sponge. So rather than running off and taking dirt with it, the water stays put within the soil.
You can just see how many pores are in here.
As a farmer, when I see this, the big pores are nice because it gets the water in, but then also seeing all those smaller pores, that's what holds the rainwater for a drought, so that when we have those big rains that come through, as much as we can get that into the soil, that's what's going to tide us over when it dries out and we have drought conditions again.
Leaving nutrients undisturbed means less money spent on fertilizers, and fewer trips across the field in a tractor saves on fuel. Across the U.S., more farmers are adopting no-till techniques. While nationwide, no-till makes up about 20% of total acres, in Iowa, that number is closer to 30%. But the necessary precision planting equipment is pricey, making any radical change in a farmer's approach costly.
Flipping a switch and entirely changing things on a farm, it's a pretty risky thing to do. And for some farmers, it takes a couple of years to really see the benefits of doing no-till.
These extreme weather events might cause more people to look at no-till as a serious option if they haven't already, because of the fact that they don't want to have intense rainfall carrying their soil away or losing that opportunity to catch water.
I think that there's a huge opportunity for farmers. It just takes time and a shift in perspective and a community of people that bring others along.
Warmer, wetter air creates intense rainstorms across the Midwest. For 100 million Americans living in coastal communities, more destructive storms are also an increasing worry.
Hurricanes are my forte. It's what I'm an expert at. And I myself have been so surprised over the years to see the number of rapid intensification cycles that hurricanes are going through.
Hurricanes are fueled by energy from the ocean. Today, during hurricane season, the Gulf of Mexico is about 1 to 2 degrees warmer than it was in the 1980s. And that warmer water supercharges storms.
I'm on the air saying, look at this thing. Look at what this hurricane is doing.
So a historic event in itself.
Recent hurricanes blow away previous records for destruction, costing over $1 trillion in 20 years and counting.
We're not necessarily seeing more hurricanes, but we're seeing that a greater proportion of them are indeed becoming these monsters.
One place especially hard hit, the coast of Louisiana, where the Mississippi River meets the Gulf of Mexico, creating about 6,000 square miles of river delta wetlands. Here, the sea is swallowing the land.
We are on Grand Bayou in Grand Bayou Village. This is my home, and this is the home of my people, and we've been here for a little more than 400 years.
Rosina Philippe is an elder of the Atacapa Ishak Chawasha tribe.
A lot of the places where you see water, it was land, and not just land, highland, hills, hard dirt. But now, no more, none of that anymore. The land has washed away.
One study found sea level here rising at a rate 4 times the global average. Elder Chief Sherelle Parfait Dardar, a member of a nearby community, the Grand Caillou Dulac Band of the Biloxi Chitimacha Choctaw tribe, is also seeing her home threatened by land loss.
We call these skeleton trees. And when you look out and you see these trees, you know that land was there at one time, right? But all that's left is the submerged tree in water holding on for as long as it can.
The impacts of more intense storms and rising seas are felt here now, in large part because the land has already been eroded by human activity. Fed by rivers and streams across much of the continent, the Mississippi River picks up sediment and would naturally deposit it in the delta, constantly replenishing the wetlands. But starting in the 1900s, a series of federal construction projects began to interfere with that natural system. Levees to prevent flooding, dams to improve navigation. The result? Less flooding in some communities and more river trade, but also less sediment reaching the wetlands. And then, starting in the 1930s, oil and gas companies cut 10,000 miles of canals through the wetlands to reach their wells, speeding erosion even more.
And so all of this is coming together in a way that we used to have this really strong protective barrier along the Gulf Coast that just is not there anymore. Then you add rising sea levels to all of that, and it's eating away even more so at our natural barriers that we have.
Since 1935, a quarter of Louisiana's coastline has vanished. That's an area about the size of Delaware. And every 100 minutes, water claims, on average, another football field's worth of land.
As we lose land, we lose storm protections, right? So the community has become much more vulnerable over time. Yeah, they can only take so many hits.
One of the most destructive hits arrived in 2021, 16 years to the day after Katrina. A Category 4 hurricane named Ida.
Hurricane Ida was a very strong storm. I had never seen anything like that in my life.
Ida's wind speed nearly doubled as it approached the coast, from 85 miles per hour to 150. pushing a storm surge of water up to 12 feet high across the land.
You can still see blue rooftops, right? And those are tarps that are still on the roofs all these months after Hurricane Ida.
It's estimated that Ida wiped out more than 75 square miles of wetlands and destroyed about 13,000 homes in the area, including Elder Chief Sherrell's. For many, Ida was the last straw.
If you ever got up in an airplane and flew over this place, it would break your heart. Yeah, really. I remember it was my first time looking at it, you know, from a bird's eye view, and I couldn't hold back the tears. I cried seeing what had happened, you know, to my home.
As the storms get stronger, as we lose more land, people move away. People can't stay where they're not safe. And as they move away, you lose a piece of who you are.
Those who live in these wetlands are starting to confront the possibility of losing their land entirely.
If we want to remain as a people, we need to look into resettling somewhere together and trying to rebuild our lives there.
Still, Sherrell and many others are fighting to preserve their ancestral land.
We that are here, we're not going anywhere, and we have to not only protect what's still here, but work to see what can be built back.
Louisiana is working on several massive projects to protect its coast, releasing sediment into endangered wetlands, upgrading levees and seawalls, installing new floodgates. But such mega projects can take years to approve and complete. So locals are taking matters into their own hands with some innovative, low-cost solutions to buy more time.
You know, we still live on the water, by the water, and we try to make sure that we can maintain a presence here.
One idea begins with a local delicacy: oysters. A local organization gathers empty shells by the ton from restaurant kitchens. They are bagged and loaded into boats to create a new breakwater reef. Rosina travels to check out one such oyster reef near a strip of land her tribe calls Lemon Tree Mound.
Lemon trees were found to be growing there. It was a gift to the people from the Creator, so that site is of particular importance to my people.
To protect this sacred site, volunteers carefully layered 200 tons of bagged oyster shells just a few feet offshore, and then let the oyster's natural life cycle do the work. These artificial reefs become a breeding ground for new oysters. Soon after birth, oyster larvae attach themselves to the older oyster shells and begin creating their own shells. As the oyster beds grow in size and height, they weaken the waves before they reach the shore. That slows down erosion.
As you can see behind the break of the sacks, the water is more still, so it stops the wave action.
These oyster shell reefs can reduce the rate of erosion by up to 60%, according to one study. And in the last 10 years, 8,000 feet of oyster reefs have been created in the region by recycling more than 10 million pounds of shells.
The oysters being bivalves, they help to filter water. It's promoting the marine life in the area. So it's just a win-win. From the waters to the table, you know, and back into the waters, we're completing a cycle and just continues to pay forward.
And Louisiana isn't the only place where oyster reefs have caught on. Since 2010, San Diego, San Francisco, Galveston, the Chesapeake Bay, and New York City have also embraced oysters in an effort to hold back the waves. But in none of these places is the need for a solution more immediate than here in Louisiana.
There are so many things that need to happen to combat the critical losses that we're facing here in coastal Louisiana, in conjunction with other larger projects that will take the next 10, 20 years to implement. These type of projects can go into the environment in a year's time, 2 years, really quick. So you will see the benefits of having them in place, and I think we all win because of that.
Extreme weather is changing lives all across America.
Climate change is loading these weather dice against us, making our heat waves more dangerous and more frequent, making our heavy rainfall more intense, making our droughts stronger and longer lasting, our hurricanes to intensify faster and dump a lot more rain on us.
People are waking up to the fact that adapting to these extremes is something we're all going to have to do, some sooner than others.
We are on the front line. Many places could benefit from paying attention to the challenges that we're going through so that maybe they can start to address those challenges a lot sooner.
The search for creative solutions is on, and forging new collaborations.
Not only do we have this Western fire science that we're using, we also have indigenous knowledge that goes back for thousands of years.
We know that there are things that we can be doing better, and we work together to make those changes. And I think that that's what gives me hope for the future.
The solutions might start small, but they all have the potential to make a difference.
We need solutions across the board. We need the big systems changes, but at the same time, our individual actions and our smaller scale solutions, the really cool projects that are happening all around the country right now, are so important.
I'm an all hands on deck type person, so let's do all of those, the local scale actions and the large policy as well. We know what needs to be done. We just have to have the will to act and do it.
This episode is part of PBS's Earth Month celebration. Check out more than 20 new videos on this playlist from our friends at Be Smart, Weathered, PBS Nature, Eons, and more. And tell them Nova sent you.